Molecular formulas. Let's see if we can write the formula for ethane, given the evidence below that the percent composition of ethane is 80% carbon and 20% hydrogen. And then if we write the correct formula for ethane, it's going to have a molar mass of 30 grams per mole. So if you're going to be able to write a molecular formula, sometimes called the true formula, the real formula, you're going to need two pieces of information to accomplish this task. You're going to need an empirical formula first, and then you're going to compare the empirical formula's molar mass to that of ethane, which in this case is 30, to see if we can write what is called the molecular formula. So to begin, let's write the empirical formula for ethane using the percent composition that is provided. The first step to write an empirical formula is we need to take our percentages and we need to change them to grams. If we assume a 100 grams sample, our percentages will actually become the grams. The value doesn't change because obviously the percentages add up to be 100, and if you assume a 100 gram sample, the number stays constant. So as you can see, we have changed our percentages to grams. We have completed step 1 in our flow chart. Now what we want to do is we want to be able to take units of grams and change it to moles. So we're going to need our periodic table for that. We're going to have to look up the atomic mass of carbon and the atomic mass of hydrogen so that we can change grams to moles. Using that carbon is worth 12 grams per mole from the periodic table and hydrogen is worth 1 gram per mole, we can divide the mass as provided by the number on the periodic table, the atomic mass, and by doing so, hopefully we're going to see that the units of grams are going to cancel, leaving us with the unit of a mole. So we've just completed step 2. We changed our grams into moles, and now we're ready to set up a ratio, hopefully the simplest whole number ratio between the carbon and the hydrogen. So let's go on to step 3. Let's calculate our mole ratio. Dividing through by the smallest, in this case the smallest number is the 6.67. And sure enough, we do get whole numbers here. We get 1 carbon and 3 hydrogens, so our empirical formula is CH3. So this is the first piece of information that we need to be able to write our molecular formula, our real formula, the true formula, if you will, for ethane. But CH3 is definitely the empirical formula based on the percentages that are provided. So now let's go ahead and let's look at that second piece of information that was provided. We know that our molar mass needs to add up to be 30 grams per mole. But if we look at our empirical formula here, we see that the molar mass is only adding up to be 15. Because we have 1 carbon worth 12 and 3 hydrogens each worth 1, that molar mass adds up to be just 15. But the second piece of evidence or information, if you will, that was provided is that ethane has a molar mass of 30. Sometimes an empirical formula can be a molecular formula. They can be the same. But in this case, that's just not true because 15 obviously is not 30. So how are we going to be able to get 15 to 30? Well, we've got to decide what factor we can multiply our empirical formula by to make it become the molecular formula's molar mass. So let's take a look at that. If we multiply by 2, we're going to be able to take the 15 up to 30. And that's going to change our empirical formula from the simplest whole number ratio to the real formula for ethane. So if we multiply CH3 times 2, so we're trying to go from 15 to 30, we end up with the C2H6, which is the real formula, the true formula, what we call the molecular formula for ethane.